Hello everyone, very good evening. How are you guys? Now today I am going to cover diode circuits for HPCL 2024 recruitment. And as you know, that is what analog is also important subject, right? So let me know that sound quality, picture quality, everything is fine. Yes, please everyone, please join the session now. And within 1 hour we are going to cover what complete diode circuit. We will start from what rectifier, then what clipper, then clamper, and then voltage doubler, and finally voltage regulator. This is a quick revision series, guys. Okay, and I have around 5 sessions for analog. Then after that I am going to start new subject. So stay tuned with me, subscribe the channel, and let me know that sound quality, picture quality, everything is fine. Yes, please. Okay. I think sound quality, picture quality, everything is fine. Yes, please. Now guys, this is a HPCL 2024 preparation series and analog electronics. Quick revision with questions, diode circuits, rectifier, clipper and clamper. Okay. And at the end I will solve some previous year question from HPCL. Okay. First of all, that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008. Okay, and now how to crack HPCL exam. Already I have taken one session for that. तो आप जाइए उसको देखिए और वहां से स्ट्रैटेजी समझिए, राइट? तो वो आपको चैनल में लिंक मिल जाएगा और साथ में आप एनालॉग कंटिन्यू कीजिए. ओके, एंड दैट इज माय शेड्यूल फॉर एनालॉग गाइस फॉर HPCL 2024. Already I have taken general session, revision strategy, what should be the strategy to crack HPCL. And then guys, today we are going to cover diode circuits. Then after that BJT, complete idea about the BJT on 17th. Then complete idea about the FET, AC analysis as well as DC analysis, biasing and amplifiers, each and everything about that, MOSFET. And then finally guys, most important topic, that is what operational amplifier. Okay, that is from analog. In operational amplifier we will cover all type of oscillators and so on. In BJT and FET we will also cover what feedback concept, different types of amplifiers. Okay, multi-stage amplifier we will cover in this topic. So these are the broad classification 1, 2, 3 and 4, daily 9 PM. Okay, so please join that, and if you want to give any feedback, then in comments box you can give your feedback also. Okay, so everyone, first of all, like the session now. Then this is my Telegram channel. If you want the PDF of this session, right, then you can join my Telegram channel, that is Electronics by Sanjay Rathi, where I will upload the PDF after this session. So you can, just for quick revision, you can go through that PDF. Okay, now so this is a HPCL short term course. That was the general session. So please watch that. Quick revision, PYQ session and marathon. And what is the tentative date? 18th of August. 18th of August, that is the tentative date for HPCL. Now guys, just diode circuits. So just a broad classification. What is the diode circuit? Simple diode, two terminal device, anode and cathode, right? And diode circuits means application of the diodes. Application of the diode means what? Rectifier, clipper, clamper, voltage doubler, sampling gates, and what? Voltage regulator. So mostly we are getting question from these topics. So within quick revision you will get the idea how to solve the questions. So stay tuned with me for last 1 hour, right? अब 1 घंटे तक आप यहाँ बने रहिए, आपका पूरा रिवीजन हो जाएगा और आपको चीजें भी समझ में आ जाएंगी. और साथ में अपने दोस्तों को भी बुला दीजिए, शेयर कर लीजिएगा. That is our channel Prep Funda by Sanjay Rathi, and for any detail you can call at this number 9899 40096. Okay, I think it is visible to you. Then guys, first of all, if you want to convert the AC into what? DC, we are having the supply. What is the supply here? Quick revision for that. So we are having the supply here. Normally it is written 230 volt 50 hertz. Everyone tell me what is the 230 volt, peak value or RMS value? Now this AC supply is given here. What is the DC value of that? 0. So we are first of all using the transformer to just step up or step down this signal. Normally we are step down. This is the N1, this is the N2. Here the signal is called Vm sin omega t. Here the signal is called Vp sin omega t. Vp by Vm is equal to N1 by N2. Then we are using the rectifier. We are having the different types of rectifier, half wave rectifier, full wave rectifier, bridge rectifier, standard type transformer type. Now this rectifier will convert the bidirectional waveform into unidirectional, and that will be the question. What is the basic purpose of the rectifier? The basic purpose of a rectifier is to convert bidirectional waveform into unidirectional. Remember, क्या होता है ना, sometimes आप लोग आंसर लिख देंगे it will convert AC to DC. No, bidirectional, this is the bidirectional, is converted into unidirectional. It may be half wave, it may be full wave. Now we are using the filter. In filter we are using the capacitor or inductor or LC filter or pipe filter. Now why we are using the filter? To just remove the AC component, and this AC component is called ripple. So here we are having the two things, AC plus DC, at the output of the rectifier, that is called pulsating DC. Pulsating DC. Just to remove this AC, that is also known as ripple. Also known as ripple, we are using the filter. What will be the question? What is the basic purpose of ripple? So ripple, what is the basic purpose of filter? Filter is used to minimize the ripple at the output of rectifier. That is the basic purpose in this case. And finally, we are using the voltage regulator. So we are having the output like this. Again, it has some AC signal variation. Now after regulator, we are getting the pure DC signal. That is the pure DC signal. Okay, so that is the output. And this is called the block diagram. Okay, so that is the first case. How we are going to convert the AC into what? DC. Now, one by one, we will cover rectifier, then filter, then what? Voltage regulator. And in between, we will cover what? Clipper and clamper also. Then, now, rectifier means half wave rectifier, that is also known as HWR, full wave rectifier, FWR. There are two types. One is called center tapped transformer type. One is called what? Bridge rectifier. Both are full wave rectifier, center tapped transformer type, and what? Bridge rectifier. Both are full wave rectifier. Now, watch this. Second thing, important parameters. Suppose if you are going to solve some questions from rectifiers, then they will ask what? Some important parameters. What are the parameters? First of all, supply frequency. Supply frequency, what is the supply frequency in India? 50 Hertz. And what is the supply frequency in USA? 60 Hertz. These are the supply frequency in India and in USA. Then that is called what? Ripple frequency. Now, what is the meaning of the ripple frequency? Remember, at the output of the rectifier, we are having this type of signal. This is the DC plus AC. And DC, what is the frequency of the DC? 0. And what is the name of the AC? Ripple. So at the output of rectifier, we are having the DC plus AC, and that AC component is called ripple, and the frequency of that ripple is called ripple frequency. This is called ripple frequency, right? So what is the ripple frequency? Frequency of AC component at the output. So ye hai. So now what is the ripple frequency in case of half wave rectifier? What is the ripple frequency in case of full wave rectifier? We have to find, and that will be the question. Okay, I will give you the value. Then RMS value, that is called root mean square value. Then DC value, that is called average value or DC value. Now what is the form factor? So in every case, you have to find the form factor. That in signal and system, they will ask what is the form factor, what is the crest factor, what is the ripple factor. तो यहाँ भी एक important parameters है. So what is the form factor? Everyone tell me. What is the form factor? Form factor है RMS value upon DC value. RMS value upon DC value, guys. Okay. तो आप जरा देख लीजिएगा. 1 minute. Okay. चलिए. Now this is the RMS value upon DC value. Form factor. That may be the question. What do you mean by the form factor? What is the ripple factor? RMS value of the AC component upon DC. Now at the output, we are having the two signal, AC plus DC. when we are finding the RMS value of the complete signal, that is called VRMS. This is the RMS value of the output DC plus AC upon VDC, then it is called form factor. Now when we are calculating the RMS value of the AC component only AC component upon DC, then it is called what? Ripple factor. That is the difference between the form factor and ripple factor. Now next one is what? Crest factor. That is called peak upon RMS. What is the peak value of the output? Like this is the VM, and what is the RMS value of the output? So peak upon RMS is called what? Crest factor. And then I will discuss this point, peak inverse voltage and what? Transformer utilization factor. तो ये दो है important again parameter. तो we will discuss peak inverse voltage and transformer utilization factor, and we will discuss all the factors for half wave rectifier, bridge rectifier as well as center tapped transformer type. Till this point, is there is any doubt, guys? Any doubt? So everyone, that is my new channel, and here I am going to cover some important subject. बहुत सारे important subject आएंगे, एनालॉग के टॉपिक्स आएंगे, ईडीसी के टॉपिक्स आएंगे, ओके, नेटवर्क होगा, डिजिटल होगा, आपके कोर सब्जेक्ट भी होंगे, हमारे भी कोर सब्जेक्ट्स होंगे एंड सो ऑन. तो आप याद रखिए, बस आपको तैयारी अच्छे से रखनी है और ये मत सोचिएगा कि आपका निकल पाएगा या नहीं निकल पाएगा. अगर सिस्टमैटिक ढंग से पढ़ रहे हो तो जरूर आप सेलेक्ट होने वाले हो. तो बस आप सब्सक्राइब कर लीजिएगा ताकि आप लोगों को नोटिफिकेशन मिलता रहे, और टेलीग्राम चैनल ज्वाइन भी कर लीजिएगा. ओके, अब देखो जरा, ये तो हो गए फैक्टर्स. अब आती बात कि आपको क्वेश्चन पूछेगा व्हाट डू यू मीन बाय द रेक्टिफायर एफिशिएंसी एंड व्हाट इज द रेक्टिफायर एफिशिएंसी फॉर हाफ वेव रेक्टिफायर, फुल वेव रेक्टिफायर. One by one I will discuss all the parameters. What is the meaning of the rectifier efficiency? Actually we are giving input DC signal and we are just converting it into what? AC signal. So we are giving the AC and rectifier will convert into DC. So how much percent of AC power is converted into DC? That is called rectifier efficiency. So rectifier efficiency means output DC power upon input AC power. So how much percent of input AC power is converted into DC power? That is called rectifier efficiency. Okay, ये एक term आएगा efficiency. Then what is the transformer utilization factor? Watch the first block diagram. At the input we are having the transformer, or in this block diagram we are having the transformer, rectifier, filter, regulator and so on. This device, transformer, is heavy as well as what? Costly. And that's why we want effective use of this transformer. So what should be the transformer utilization factor? It should be as high as possible. It should be as high as possible. So we want 100%. 100% means 1, right? But normally, practically it will be less than 1. So what is the transformer utilization factor for half wave rectifier? Then center tapped transformer type. Then what? Bridge rectifier we will discuss. So this is the important parameter. Okay. अब आती बात PIV. What do you mean by the peak inverse voltage? Peak inverse voltage means what is the maximum voltage appearing across the diode when the diode is reverse biased? Okay, everyone tell me. In this question, what is the maximum voltage across the diode when the diode is reverse biased? Tell me guys, this is the 20 volt. This is our ideal diode. What is the PIV for this diode? What is the PIV for this diode? So what is the peak voltage appearing across the diode when the diode is reverse biased? So this is because of 20 volt it is reverse biased. It will act as what? Open circuit. Then the complete voltage will come across what? Diode, or in a reverse direction. And that's why what is the value of the PIV? 20 volt. So everyone give me the answer in comments box also. 20 volt. 20 volt चाहिए. ये हो गया 20 volt. So this is called what? PIV. This is called PIV. So why we are calculating the PIV? Because we want up to this maximum voltage, this diode should remain what? Open circuit. It should behave like what? Unidirectional device. When it is forward bias, it will allow the current. When it is reverse bias, it should not allow the current. तो हमको चाहिए, if it is diode, Forward bias, it should act as short circuit. Reverse bias, it should act as what? Open circuit. So we are calculating the PIV. What is the voltage appearing across the diode, so that it will act as open circuit up to that voltage. तो हम लोग क्या करते हैं, डायोड सेलेक्ट करते हैं ऑन द बेसिस ऑफ व्हाट? PIV रेटिंग. तो ये आप याद रखिएगा, ऑन द बेसिस ऑफ PIV रेटिंग वी आर सेलेक्टिंग द डायोड गाइस. तो ये आपका क्वेश्चन आता है. मैं आपको एक क्वेश्चन भी देता हूं, जरा बताइएगा क्या आंसर आएगा. जैसे बहुत ही बेसिक से क्वेश्चन आएंगे. डेफिनेशन आएगी. अब मैंने आपको डायोड लगा दिया, ध्यान दीजिएगा, बहुत ही सिंपल सा क्वेश्चन. ये डायोड लगा हुआ है. एवरीवन टेल मी व्हाट विल बी द आंसर. ठीक है, बताइए व्हाट इज द PIV ऑफ द डायोड from this diagram. This is the 30 volt, this is the 20 volt, that is the 10 ohm. What is the PIV for this diode? They will give you the very basic questions, very basic question like this, right? So what is the PIV? Definition is important. Then what is the PIV for this? This is a very basic question. Then always remember, first of all, find the voltage across this. Let this diode is reverse bias, it will act as open circuit. So what is the voltage across this 10 volt? 10 divided by 10 plus 20 into 30. That is the 10 volt. Means that diode is reverse biased by what? 10 volt. That diode is reverse biased by 10 volt. So what is the PIV for this diode? 10 volt. तो ये आ गया क्वेश्चन आपका. PIV for diode is what? 10 volt. Okay. तो जरा भाई एक बार सब लाइक कर लीजिएगा और सब्सक्राइब जरूर कर लीजिएगा चैनल. देखो ये अभी मैं आपको बता रहा हूं ताकि आप लोग का नोटिफिकेशन मिस ना हो. बहुत सारे सेशन होने वाले, राइट? तो ओके वामसी, यू हैव गिवन द राइट आंसर, दैट इज व्हाट? 10 वोल्ट. गुड. तो ट्राई टू गिव मी द आंसर, राइट? सबके सब आंसर भी जरूर दीजिए. आपके कमेंट्स मुझे दिख रहे हैं. एक मिनट रुकिएगा जरा. यस, ओके, नाउ. Yes, Vamsi, your answer is correct. Now, next one. This is called PIV. So, PIV for different, we will discuss. First of all, what about the diagrams, guys? Watch this diagram first. This is a half wave rectifier. This is a half wave rectifier. We are connecting 10 volt. This is the transformer. This is the 10 volt. This is the RL. We are giving the sinusoidal signal here. Watch this. This is the sinusoidal signal. Normally we are saying that this is the VP. In every question, if the VP is written as 230 volt 50 hertz, always remember guys, if nothing is given, this is the RMS value. This is the RMS value. So what is the peak value? Peak value will become RMS value into root 2. 230 into root 2 is the value of the VP. Now on the secondary side, voltage is represented by Vm sin omega t. Normally it is represented by Vm sin omega t. So always find Vp by Vm is equal to what? N1 by N2. In particular question, they will give you the transformer turn ratio, N1 by N2. So always remember, if nothing is given, that 230 volt is the RMS value. First of all, convert it into peak value and then you can find the Vm. Now, because everything depends upon the Vm, so you have to find the Vm. Then, now this is a half wave rectifier. So for half wave rectifier, in positive half that diode is on, in negative half that diode is off, and that's why, because for this input we are getting this type of output. This type of output. This is the half wave rectifier. Now what are the different questions on half wave rectifier? So that is a quick revision. First guys, if you are getting this type of output, what is the RMS value of this? So Vrms is equal to Vm by 2. So that's why this voltage is important on the secondary side. Answer in terms of Vm. What is the DC value of this? Vm by pi. What is the ripple form factor for this? Form factor is Vrms upon Vdc. When we are dividing these two, you will get 1.57. Then what is the ripple factor? Ripple factor is equal to VAC RMS upon VDC. Already I have given you the definition, that is written as F square minus 1. फॉर्मूला भी याद रखिए, व्हाट इज द रिपल फैक्टर, रूट ओवर एफ स्क्वायर माइनस 1। तो एकदम सिंपल सा क्वेश्चन आ सकता है, लेट दिस इज द फॉर्म फैक्टर, देन व्हाट विल बी द रिपल फैक्टर, टेल मी गाइस व्हाट इज द रिपल फैक्टर इफ द फॉर्म फैक्टर इज 1.57 फ्रॉम दिस फॉर्मूला, or directly if you have the idea then you can find the ripple factor also. Then ripple factor, then crest factor, peak upon RMS. What is the peak value of the output, Vm? What is the RMS value of the output, Vm by 2? So you will get 2 crest factor. Then what is the PIV, peak inverse voltage? What is the maximum voltage appearing across the diode when the diode is reverse bias? That is nothing but Vm. This is again in terms of that. Now next question, what is the transformer utilization factor? Transformer utilization factor is only 0.286, underutilization, only 0.286 underutilization. Remember, that may be the question. What is the transformer utilization factor for half wave rectifier? Now what is the efficiency, eta max rectifier conversion efficiency? The AC power is converted into DC power. Maximum is what? 40.8. So 40.8, right? 40.6. 40.6. So this is the maximum. मतलब 40.6% AC power is converted into DC and the remaining power is in the form of AC. Okay, to 40.6, very low efficiency, right? Ripple factor, what is the value of the ripple factor, guys? You are not giving the answer. So these all are the parameters for half wave rectifier. This is the parameter for half wave rectifier. So ये है values. Now because efficiency is very low, form factor is very high, ripple factor is very high, crest factor is very high, and that's why we have to use what? Full wave rectifier, bridge rectifier. अब एक बात बताओ, what are the ideal value of form factor, ripple factor and crest factor? How we can say these are the high values? So remember guys, ideal value, this will be the question, ideal values. So what is the ideal value? So actually we want pure DC signal. For rectifier, what are the ideal value? Let this is the, we are getting the pure DC signal. Pure DC signal. Let this is the pure DC signal. What is the value? Vm. Now this is the, if suppose it is the output ideal condition, then what is the peak value? Vm. What is the RMS value of DC? Vm. What is the DC value? Vm. What is the AC component? 0. There is no AC component. So first of all, what is the ripple factor? AC component upon VDC, 0. This is the ideal value of the ripple factor. What is the form factor? VRMS upon VDC, it will become 1. What is the crest factor? Peak upon RMS, 1. These are the ideal values. Remember guys, these are the ideal values. So you have to use these ideal values. Now for half wave rectifier, we will getting 1.21, that is a very high. So this is the value 1.21. Then form factor is 1.57, ideal value is 1, crest factor is 2. तो देखिए कितना ज़्यादा है ये, right? So ideally say as compared to ideal, these are very very high values guys. Okay, so we want ideal values. Now this is about the half wave rectifier and that is the diagram. Now second one is what? Center tapped transformer for type full wave rectifier. Center tapped transformer type full wave rectifier. Are you enjoying the session guys? तो जरा थोड़ा सा कमेंट्स और थोड़ा हार्ट और ये सब सेंड करते रहिएगा और एंजॉय करो सेशन, राइट? पैनिक मत होना, एग्जाम के बारे में ज़्यादा मत सोचो, आप अपना काम करो, अच्छे से पढ़ो, अच्छे से नोट्स बनाओ, शॉर्ट नोट्स बनाओ. इन केस ऑफ HPCL एग्जाम, प्लीज वॉच द प्रीवियस क्वेश्चन पेपर, राइट? क्वेश्चन अप टू व्हाट सरफेस लेवल. तो क्विक रिवीजन, जस्ट गेट द क्विक रिवीजन एंड ट्राई टू सॉल्व क्वेश्चन लाइक दैट. ओके, क्योंकि 3 फेज होंगे ना. सेकंड फेज में आपको और भी ग्रुप टास्क मिलेगा, फिर थर्ड फेज में इंटरव्यू होगा, इसीलिए जो फर्स्ट फेज है ना वो लाइट है. अब आपको यही चीज समझाने के लिए गेट और अगले अलग PSUs में पेपर में इतना डिफरेंस क्यों होता है, आई एम गोइंग टू टेक वन सेशन. व्हाट इज द सेशन? gate is difficult, myth or fact? It is a comparative term. Why gate is difficult? क्यों हमको ऐसा लगता है कि गेट डिफिकल्ट है जबकि ऐसा है नहीं? तो व्हाट आर द इंपॉर्टेंट पॉइंट्स आई एम गोइंग टू डिस्कस. तो यहाँ पे आपको चैनल में पता चल जाएगा. अब देखो, फुल वेव रेक्टिफायर सेंटर टैप्ड ट्रांसफॉर्मर टाइप. वॉच दिस, देयर इज अ सेंटर टैप्ड ट्रांसफॉर्मर टाइप. Here we are having the two diodes 1 and 2 and RL is connected here. This is a full wave rectifier. Full wave rectifier means we are getting this type of output. This type of output. Now, if we are getting this type of output, then what are the important factors? First of all, half wave, then full wave. In full wave, we are getting this type of output. In half wave, we are getting this type of output. First, it will repeat after that point. It will repeat after that point. So, what is the time period of the output is equal to time period of the input. So, what is the frequency of the output? It is the frequency of the input. Means in case of half wave rectifier, the frequency of the output is equal to supply frequency. And the frequency of output is called ripple frequency. So that's why in case of half wave rectifier, ripple frequency is equal to supply frequency. In India, supply frequency is 50 Hz. But in case of full wave rectifier, after that it will repeat. So what is the time period will become? T by 2. Half of the input signal, because that is the input signal. That is the input signal, guys. And this is the time period of the input signal. So what is the time period of the output? Half. What about the frequency? Double. That's why the ripple frequency is 100 Hz if you are in India and 120 Hz if you are in USA. तो ये है double just in case of full wave rectifier. First comparison, and that is the value. Second, in case of full wave rectifier, when we are finding the RMS value, that will become Vm by root 2. In case of half wave, it is Vm by 2. VDC will become double, 2 Vm by pi. Right? And then a form factor, Vrms upon VDC, that will become, you can value 1.11. Ripple factor, 0.48. Right? Crest factor, root 2. Peak upon RMS, it will become root 2. Transformer utilization factor for center tapped, 0.693. And that is the transformer utilization factor. So guys, now as compared to half wave, it is near to ideal value. 1.11 near to 1.48 near to 0, root 2 near to 1. And that is the transformer utilization factor near to 1. It should be as high as possible. So ये भी आ गया. So, and finally, what is the efficiency? Efficiency is 0.812 or 81.2%. Means as compared to half wave, just double. 81.2% of AC is converted into what? DC. Or in case of half wave, only 40.6%. ये double हो गया. So these are the important parameters for full wave rectifier center tapped. Now, what is the PIV? What is the PIV? That is the drawback. PIV, peak inverse voltage, is 2 Vm, high value. High value. That is the drawback of this center tap transformer. Second drawback is what? Center tapped transformer itself. Means it is a very bulky and heavy and costly device. This is a center tapped. And that's why this circuit is not preferable for what? High voltage application. PIV is high. PIV depends upon the Vm. So if we are increasing the input, Vm will increase, PIV will increase. And the size of the transformer will also increase. And that's why it is not preferable for high voltage application. It is preferable for low voltage application. Now, for high voltage application, we are using the bridge rectifier. That is the bridge rectifier. Watch this. This is also a full wave rectifier. So full wave rectifier, we are having the 4 diodes here. 1, 2, 3, 4. Or in this case, we are having the 2 diodes. That is the difference between the center tapped transformer and what? Bridge rectifier. Now, what are the different points? Different points means in a full wave rectifier, again in case of bridge rectifier, we are getting this type of output. For this, Vrms will remain same, Vm by root 2. VDC will remain same, 2Vm by pi. That's why form factor is 1.11, ripple factor is 0.48, crest factor is root 2. Now, when we are comparing with full wave rectifier, center tapped transformer type, what is the difference here? Full wave rectifier means center tapped transformer. So what is the PIV in case of bridge rectifier? Vm. But in case of center tapped, it was what? 2 Vm. So just half. And that's why we can use it for what? High voltage application. High voltage application. So ये है PIV. But guys, at a time we have to turn on the two diodes. At a time we have to turn on the two diodes, because two diodes are acting in series, and that's why cut-in voltage is high. Or at a time in case of center tapped, only one diode will conduct and next one is off. So what is the cut-in voltage? Only V gamma is required. So in case of bridge rectifier, cut-in voltage is high. Cut-in voltage. What is the minimum voltage required? That is what? 2 V gamma. Or in case of center tapped, it is what? Only V gamma. What is the cut-in voltage? V gamma. That is the difference between what? Bridge rectifier and center tapped transformer. So that may be the question. बहुत सिंपल से क्वेश्चन आते हैं. ऐसा सर्किट बताओ जिसमें 2 डायोड लगे होते हैं, सेंटर टैप्ड ट्रांसफॉर्मर. ऐसा रेक्टिफायर बताओ जिसमें 4 डायोड लगे होते हैं, ब्रिज रेक्टिफायर. तो कंस्ट्रक्शन डिटेल में भी आपका कंपैरिजन आ जाता है, राइट. दूसरा, यहां आप देखोगे ना सेंटर टैप में, तो दिस RL is what? Grounded. One terminal is connected to rectifier, other terminal is connected to what? Ground. This is called grounded load. Here it is called what? Floating load. No terminal is connected to ground, and that's why it is called what? Floating load. Remember, what is the floating load? Because no terminal is connected to ground. Next, in center tapped, if suppose step down is not required, you can't connect the direct input. Without transformer, you can't connect, because the complete function depends upon a transformer, and that's why we can't connect input directly. But in case of bridge rectifier, we can directly connect the input without transformer or with the transformer, both possible. For example, in this case we are directly connecting the input. If suppose step down is required, you can what? Change it, or here you can connect what? Transformer. Here you can connect the transformer. If suppose the transformer is not required, remove it. Required, then yes, you can connect it. Both possible. This circuit will work. Here you can connect the input, but here directly you can connect or indirect. But in case of center tapped transformer, you can't connect. You have to use this center tapped transformer. So that is the biggest advantage of what? Bridge rectifier. Bridge rectifier is preferable for high voltage application because its PIV is less. तो देखो आप इतने क्वेश्चन आएंगे, सब बना लोगे आप लोग. तो शुरू से जो नए स्टूडेंट है प्लीज शुरू से देखिएगा आप. This is the table I am going to provide you. If you want, right, I think that number is visible to you, yes or no, you can message me on this number, or you can join my Telegram channel. That link is given in description. Electronics by Sanjay Rathi, where I will upload the PDF of this session. Okay, तो देखो यहाँ पर पूरा लिखा हुआ है. रेक्टिफायर, रिपल फ्रीक्वेंसी F, DC value Vm by pi, Vm by 2, 1.57, 1.21, crest factor, PIV, transformer utilization factor. Full wave center tapped F, 2F, 2F. 2F is the supply frequency. Ripple frequency double, 2 Vm by pi, 2 Vm by pi, Vm by root 2, Vm by root 2, 1.11, 1.11, 1.57, 0.48. And what is the transformer utilization factor for bridge rectifier? 0.812, highest among 3. It is only 0.286, 0.693, and it is a 0.812. So transformer utilization factor is highest for bridge rectifier. Okay, so that is a very important table for all competitive exams. No doubt it is a session for HPCL, but it is also applicable for other competitive exams, guys. Okay, ये तो हुआ about rectifiers. Now filters guys. Why we are using the filters? तो ये है फिल्टर सर्किट, ठीक है। अब आते हैं हम लोग फिल्टर सर्किट पे। तो भाई जितने भी न्यू स्टूडेंट्स है, फर्स्ट ऑफ ऑल सब्सक्राइब चैनल अभी कर लीजिएगा, ओके, एंड लाइक द सेशन so that you will get the notification about all my sessions and so on. बिल्कुल टेक्निकल बातें होंगी, मोटिवेशनल लेक्चर्स होंगे, स्ट्रैटेजी डिस्कस करेंगे, हाउ टू क्रैक दिस एग्जाम, राइट। जो भी आपको प्रॉब्लम है मैं अपना एक्सपीरियंस आप लोगों के साथ शेयर करूंगा, कैसे इन एग्जाम्स को लेना चाहिए। और एकदम आप नॉर्मल स्टूडेंट, आपको लगता है कि मैं कर पाऊंगा या नहीं कर पाऊंगा, तो भी आपको कॉन्फिडेंस आ जाएगा कि यस आई कैन क्रैक दिस पर्टिकुलर एग्जाम गाइस। तो थोड़ी लंबी जर्नी है, नेशनल लेवल के एग्जाम्स हैं, तो थोड़ा आप टच में रहिए। नाउ at the output of rectifier we are having pulsating DC. This is called pulsating DC. Pulsating means AC plus DC. Just to remove the AC component, this is known as ripple, we are using the filter. It is not like what half wave, not like a high pass filter, band pass filter, band reject filter. No. Here filter means what? Just जैसा होता है ना, किसी को छान के बाहर निकालना है तो filter out करना है। तो here filter means what? Just we have to minimize the AC component and pass the DC component. So here we are having the different types of filters: capacitor filter, inductor filter or choke filter. So normally we are using the capacitor and inductor. L section filter, LC filter, pi or CLC filter, pi or CRC filter. One by one I will give you the diagram and I am going to cover the important points here, or at the end we will discuss the ripple factor. Okay. Now, first of all, this is the half-wave rectifier with C filter. Here we are connecting the C. Always remember, capacitor is connected parallel with RL. Capacitor will connected parallel with RL. First thing. Second thing, value of capacitor is very high. They will ask what should be the value of the capacitor. It should be low, moderate, or very high. So it should be very high. Always remember, capacitor act as open circuit for DC. That's why what is the DC component? 0, and it should pass the AC component. Here we are having the two component, AC plus what? DC. So DC will pass through the RL and AC will bypass through what? Capacitor. And that's why the value of capacitor should be as high as possible. Sometimes we are having in the range of what? 4 millifarad. Normally we are using capacitor in range of microfarad, but here we are having the millifarad, very high. This is a very high capacitor. Now in case of center tapped transformer type, this is the parallel connected to parallel, again the value of the capacitor should be very high, right? So that is the case. Again in the case of bridge rectifier, it is connected to parallel with RL. This is the parallel with RL, CRL, right? That is the case. Then here, if suppose that is the advantage, it will reduce what? AC component, and there is an improvement in what? DC component, but there is some drawback. In case of half-wave rectifier, initially without filter PIV was VM. Now the PIV will become 2 VM. Or PIV should be as low as possible. So ye just double with filter, and that is the drawback of this circuit. Just double, okay, 2 VM. Here, in case of center tapped transformer, without filter it was 2 VM, with filter it is 2 VM. There is no change in PIV. In case of bridge rectifier, without filter it was the VM, with filter it remain VM. Means only in case of half wave rectifier PIV will change from VM to what? 2 VM. In bridge remain same. In center tap remain same. That is the drawback. Second case, just to charge the capacitor, guys, just to charge the capacitor, when we are using the capacitor, high current will flow through the diode, and therefore the diode current will increase. Remember, high diode current is required, right, for charging of the capacitor. So first drawback is what? PIV will change. Second drawback, that is general in case of half wave, bridge and so on, current through the diode will increase. And what is the advantage? Ripple factor will decrease because ripple will decrease, AC component will decrease, and that's why finally the ripple factor will decrease. Okay, तो ripple factor decrease होगा, वो देखते हैं हम लोग. फॉर्मूला एट द एंड में आपसे डिस्कस करूंगा. नाउ कैपेसिटर कहां कनेक्ट होता है? पैरेलल में. But inductor is connected in what? Series. Watch this. This is the rectifier and that inductor is connected in series with RL. Capacitor parallel, inductor series, and the value of this inductor again very, very high. And if it is the AC component plus DC component, always remember inductor acts as a short circuit for DC because JL is equal to what? J omega L. Omega for DC is 0. That's why this will act as short circuit. It will pass the DC component and it should block the AC component, and that's why its value should be as high as possible. Again, but it is connected in series, right? It is in connected in series. It is in connected in series, right? Now, what should be the value of RL? In case of capacitor filter, value of RL should be high. Value of load should be high. Capacitor high. So what is the time constant? It should be high. High. And that then it will work properly. Means capacitor filter is used for high load resistance. Now, what about the inductor filter? Inductor should be high. Resistor should be low. It is preferable for low resistance. And what is the time constant? L by RL. So time constant again, L is high, RL is low, and that's why time constant is very high. In both the cases, we want high time constant. In one case, RL should be high. In case of inductor, RL should be low. And that is the difference between what? Inductor filter and capacitor filter. Basic type of questions. No numericals, theoretical questions. And that is, it is connected in series, and that is the case. Now, here we are using LC filter. LC filter. LC means what? L section. What is this? This is the L section. This is the L section. Right? तो ये है LC filter. Inductor is connected in series. Capacitor is connected in what? Parallel. Okay. What is the advantage now? Why we are using? Remember guys. When we are using only one element, for example capacitor parallel to RL, ripple factor should be as low as possible. So if suppose you are using only one reactive element, a ripple factor is proportional to 1 by F. Means it is inversely proportional to what? F, frequency. If suppose again we are using the one element, that is the inductor, again the ripple factor is proportional to what? 1 by F, frequency. But if suppose you are going to use the two reactive elements, 1 and 2, the ripple factor is proportional to what? 1 by F square. And suppose the frequency is 50 Hertz. What is the square of that? 2500. That's why the ripple factor is very, very, very low. Ripple factor is what? Very, very low. So that is the beauty of that. If suppose we are increasing the number of reactive component, power of the frequency in denominator will increase. Two reactive element, F square. That's why the ripple factor is very, very low in case of L section or LC filter. Third one, pi filter. 1, 2, 3 reactive elements, and that's why F is equal to what? 1 by F cube. Ripple factor is very, very, very low in case of pi or CLC filter. Again, remember capacitor in parallel, inductor in series. Okay. So with rectifier, never ever connect capacitor in series or inductor in what? Parallel. Otherwise circuit will not work. यहाँ तक कहीं कोई दिक्कत है तो बताओ भाई, किसी को कोई प्रॉब्लम? Everyone? Okay then. So this is about the 1 by F cube, C1, L, C2. You can connect now. चलो भाई, if there is any doubt, and then तो ये आ गया आपका 1 by F cube and so on. तो ये आ गया, फॉर्मूला बताओ up to this point. If there is any doubt, Yes, please. बताओ जरा. Okay. No sir. चलिए वहां से. Now watch this. Just what we are doing. There are three elements. One, two, three. This is a very inductor is what very bulky and heavy. Sometimes we want compact circuit. What we are doing, just we are replacing the L by what? Resistor. So this is called CRC filter. So what will be the question? Why the resistors are inductor is replaced by the resistor? Just for compact circuit. Compact circuit. And what will be the ripple factor? It is proportional to what? 1 by F square. Why? Because now there are only two reactive elements. This is the resistor actually. Just for compact. So here it is a proportional to 1 by Fq, very very low. Here it is a very low, and just become the compact circuit. Inductor is replaced. This is a pi filter. Now normally there is a one resistor we are connecting. We are connecting at a resistor parallel to RL, right? When we are using the practical circuit, whether it is a C filter or what inductor filter or what LC filter or pi filter, we are connecting one RB parallel to RL. What is the name of RB? Any idea? Now, what is the purpose of this RB? Why we are connecting one resistor RB parallel to RL? Parallel to RL. This resistor is called what? Bleeder resistor. This resistor is called bleeder resistor. Right? Normally the value of RB is very very greater than RL. When we are connecting the RB parallel with RL, nearly equal to RL. So RB is greater than RL. It should be. That will be the question. What should be the value of RB? So it should be very very greater than RL. Second important thing, it is a bleeder resistor. Right? What is the purpose of the bleeder resistor? Guys, it is connected in the circuit just to avoid accident. How? So when we are connecting the bleeder resistor with what? Capacitor filter. When we are connecting the bleeder resistor, for example, this is the capacitor. Here we are connecting the bleeder resistor RB. Here we are connecting the RL. Suppose you are going to disconnect the RL, you are going to disconnect the supply. What will happen? The capacitor will discharge through RB. Capacitor will discharge through RB, or in this way we can avoid accident, right? So the charge of the capacitor will bleed off through the RB, and that's why it is called bleeder resistance. So this is the bleeder resistance. So capacitor will discharge through the RB, first thing. Second thing, when the bleeder resistor is connected with the inductor, then for its smooth functioning of the inductor, for a smooth current through the inductor, RB is required. Second thing, first to discharge the capacitor, second for smooth current through the inductor, RB is required. Third, sometimes in circuit we are using as a potentiometer. RB is used as that, it is a rectifier. So here we are using the RB, and we are using the RB as a potentiometer. For example, this is the case. We are getting the 9 volt, here we are getting the 6 volt, here we are getting the 3 volt with respect to ground. It is behaves like what? Potentiometer. Potential divider circuit. So these are the application of bleeder resistance, guys. Okay, so ये है first point, capacitor to discharge the capacitor. Second, for smooth function, smooth current through the inductor. Third is what? Potential divider. तो आपके दिमाग में कुछ और हो तो आप पॉइंट्स बता सकते हैं. Right? Now, this is the formula, but no one is going to ask you the formula. No one is going to ask you the formula for ripple factor and so on. But remember, for just for half wave rectifier, already I have given what is the dependency on the frequency and so on. But remember, one formula for half wave rectifier, the ripple factor is given by 1 by 2 root 3 FCRL. F is the supply frequency, value of C, RL. And here it is given just 2 times 4 root 3 FCRL for full wave rectifier. Here 2 root 3 FCRL, here it is a 4 root 3 FCRL. अगर आपको फॉर्मूला देखना है, that is the formula for the inductor filter, but no one is going to ask. Already I have given. Value of L should be high, value of RL should be low, right? And it is proportional to 1 by F and so on. So ये है important. So guys, this is about the rectifier and filters. I think that is a quick revision, right? Within 40 minutes. Already I have covered what rectifiers, complete rectifiers and what filters. Now just time to start what clipper. तो आधे घंटे और थोड़ा सा ट्यून रहिए तो क्लिपर पूरा रिवाइज हो जाएगा. आर यू ओके? राइट, चलिए अब देखते हैं जरा. ओके देन, क्लिपर. अब बात करते हैं क्लिपर की. तो व्हाट इज द क्लिपर हियर? If you want the PDF, then please join Telegram channel, right, where I will upload the PDF, and subscribe the channel so that you will get the notification. Now clipper. What is a clipper circuit? Just we want to limit the amplitude, then we are using the clipper circuit. What we are doing? Clipper circuit means what? Just clipper is a circuit that removes either the positive or negative parts of the waveform. This kind of processing is useful for signal shaping. If suppose you want to change the shape of the signal, circuit protection and what communication. These are also referred to as voltage or current limiters, amplitude selectors or what slicer. What are the different names of clipper circuit? Amplitude limiters, slicers or what? Amplitude selector, right? For example, if suppose this is the input signal, so sometimes we want what we want, just we want to pass the signal below some reference level, but we want to cut the signal above some reference level. For example, this type of output. What we have done, we have just cut this portion. We have just cut this portion above some reference level VR, and all the portion below that as it is. This is replica of the input. So that will limit the upper amplitude. This type of clipper is called peak clipper or what? Positive clipper. If we are clipping the input above some reference level, this is called what? Peak clipper or positive clipper. Just opposite of that. Just opposite of that. Suppose we are passing this signal, we are cutting just below. Like, what about the below? 0. But when the signal is above, it will pass. So this is called bottom clipper because we have clipped the below portion and above portion is passed. So this is called bottom clipper. Bottom clipper or what? Negative clipper. Negative clipper. So this is called positive clipper or peak clipper, and that is called bottom clipper or what? Negative clipper. Sometimes we have to cut above portion as well as below portion. So this type of clipper is called what? Two-level clipper. Two-level clipper means we are getting this type of output. We are having the one reference level above, one reference level below, and we are getting this type of output, guys. Cut, cut, and so on. What about this portion? Cut. What about this portion? Cut, and so on. We are getting this type of output. This is called one reference level. This is called another reference level. So this is called two-level clipper. So broad classification: negative clipper, positive clipper, two-level clipper. Or just we are limiting the amplitude. That's why it is called amplitude limiters. We are selecting the amplitude. That's why it is called amplitude selector. स्लाइस कट करते हैं ना, खरबो जो काटते हो, खीरा खा रहे हो आप, कुकुम्बर खा रहे हो तो आप काटते हो ना स्लाइस सैलेड में, वैसे आप स्लाइस कट कर रहे हो. दैट्स व्हाट इज कॉल्ड स्लाइसर. तो ये आपका स्लाइसर भी है. ओके, ये हो गया. अब आती बात भाई नेगेटिव क्लिपर, पॉजिटिव क्लिपर आप जज कैसे करोगे? तो उससे भी पहले एक क्लासिफिकेशन और है, दैट इज कॉल्ड व्हाट? ऑन द बेसिस ऑफ डायोड. वी आर जस्ट कनेक्टिंग द डायोड. If suppose the diode is connected parallel to RL, then it is called shunt clipper. If the diode is connected in series with RL, then it is called series clipper. आप देख कर ही बता दोगे. बताओ, ये यहां आप लगाओगे RL, डायोड इज कनेक्टेड पैरेलल टू RL, दिस इज कॉल्ड व्हाट, शंट क्लीपर। और अगर आप ये डायग्राम देखो यहां पर, यहां लगाओगे RL एंड यहां से आपने अगर लूप लगाया, देखो ये सीरीज कनेक्शन हो गया, तो दिस इज कॉल्ड सीरीज क्लीपर। नाउ what about this clipper? It is a positive clipper or negative clipper? Just you can judge, guys, very simple, you can judge very quickly, then I will give you the shortcut. Then guys, simply put the Vi here. When the Vi is, try to understand, when the Vi is less than Vr, when the Vi is less than Vr, positive portion is less than negative portion, definitely diode is off. So very simple, when the Vi is less than Vr, diode is off. When this diode is off, what is the output? You will get Vi. When this diode is off, what is the output? You are going to get the Vi. When Vi is greater than or equal to Vr, diode is on. When this portion is on, what is the output? Vr. Simple. When it is less than Vr, output is replica of the input. When it is greater than Vr, output is constant. So we are getting this type of output. When it is above Vr, it is constant. When it is below Vr, it is follow the input. Tell me guys, positive clipper or negative clipper? Positive clipper or negative clipper? That will be the signal. So this is a shunt clipper. Why? Because the diode is connected here. Diode is connected here, shunt, and it is a positive clipper because clipping above some reference level. So what is the negative clipper? Just change the polarity of the diode. Just change the polarity of the diode. It will become negative clipper or bottom clipper. Very simple. It is a positive clipper. That will become negative clipper, right? So that is the sustain. Similarly, when diode is connected in series, watch this. When diode is connected in series, this is called series clipper. Whether it is a positive or negative, very simple. For example, this is Vi. Now Vr is connected to the positive portion, Vi is connected to the negative portion. When the Vi is less than Vr, diode is on. When the Vi is less than Vr, diode is on. When the diode is on, this portion will act as short circuit. And therefore, output is exactly replica of the input. Or when the Vi is greater than or equal to Vr, diode is off. This portion will act as open circuit. There is no current through R and output is Vr. Output is Vr. Again, you are getting this type of output. If it is above Vr, output is fixed. Below Vr, it will follow the input. Which portion is cut? Positive portion is cut. Peak portion is cut. And that's what is called peak clipper or what? Positive clipper. So it is a series positive clipper. Series positive clipper. And if you want negative clipper, then change the polarity of the diode. Just change the polarity of the diode. It will become negative clipper. So this is a chart diagram hai bhai, for only 4 diagrams. 1, 2, 3, 4. 1 shunt to directly visible hai. This is what? Positive clipper. Just change the polarity of the diode. It will become negative shunt, negative clipper, shunt positive clipper. Then it is a series positive clipper. Change the polarity of the diode. That will become series negative clipper. This is the 4th one. This is the 3rd one. 1, 2, 3, 4. Right? So remember, this is a negative. ओके तो क्लिपर आप समझ लिए, बहुत ज़्यादा डेप्थ में जाने की जरूरत नहीं. क्लिपर का बेसिक पर्पस क्या है, वाई वी आर यूजिंग द जस्ट टू लिमिट द सर्किट, व्हाट आर द डिफरेंट नेम्स एंड दिस टाइप ऑफ क्वेश्चंस वी में एक्सपेक्ट गाइस. अब आते हैं जरा नेक्स्ट जो डायोड सर्किट है, दैट इज गाइस व्हाट क्लैंपर सर्किट. क्लैंपर क्या करता है, जरा थोड़ा तो कमेंट्स दीजिए आप लोग भी. बताओ भाई क्लैंपर क्या करता है, व्हाट इज द बेसिक पर्पस ऑफ क्लैंपर। मैं यही हूँ, मैं तो बताऊंगा ही बताऊंगा, अभी आज कवर करके ही जाएंगे डायोड पूरा। इफ यू आर एंजॉइंग द सेशन जस्ट सब्सक्राइब कर लेना भाई आप लोग, ओके। जरा और कमेंट्स में भी बता दो और किस सब्जेक्ट का सेशन चाह रहे हो आप लोग इसके बाद। लेकिन आपके पास चॉइस है, नेटवर्क है और डिजिटल और कंट्रोल। I'm going to cover analog, then after that or in between microprocessor, digital, network, control. चलिए अभी आगे, अभी जाइएगा नहीं, अभी तो कंटिन्यू करेंगे हम लोग यहाँ तक। इफ देर इज एनी डाउट हो गया यहाँ तक, ओके। अब आते हैं जरा क्लैंपर सर्किट पर। साउंड इज क्लियर, नो प्रॉब्लम। नेटवर्क, ओके वहां से just after we will discuss all type of filters, all the topics from the network, all important topics from what network with some numericals also, okay। चलिए अब देखते हैं जरा क्लैंपर। what is the clamper guys, just in a simple word, let this is the clamper, here we are giving the input. If suppose this is the input, guys remember it is a Vm sin omega t, so it is Vm, it is 0, it is minus Vm. So what is the swing of this? Swing means maximum minus minimum, so that is the swing is 2 Vm, that is called peak to peak value. DC value is 0, frequency is like 50 Hertz, DC value is 0 and peak is what, 2 Vm. So after passing through the clamper circuit, there may be two cases. There will be two cases. First case like this. Second case like this. This is 0, this is minus Vm, this is minus 2 Vm. Or this is 2 Vm, this is Vm, this is what, 0. Now, in that case, what is the DC value? Minus Vm. Swing, same. What is the swing? 2 Vm. What is the frequency? 50 Hertz. What is the swing? 2 Vm. What is the frequency? 50 Hertz. The swing remains same, frequency remains same, but what is the change in? Only the DC level. What is the DC level here? Vm. What is the DC level here? Minus Vm. And what is the DC level of the input? 0. Shape will remain same, frequency will remain same, swing will remain same, only there is a change in what? DC level. And that's why it is called DC level translator. It will translate from one level to what other level. It is also called DC inserter. It will introduce the DC level. It is also known as DC restorer. So that is the basic purpose of clamper circuit. There are two types of clamper. If it will introduce the negative DC level, it is called negative clamper. If it will introduce the positive DC level, it is called positive clamper. So there are two types of clamper, negative clamper and what? Positive clamper. So this is the negative and positive. Now, watch this diagram. What is the negative clamper? Very, very simple diagram, guys, because they will ask question. One capacitor is required. I am not going to explain you the function. Though it is not the time to explain each and every function, otherwise the clamper will take around 2 hours. 2 घंटे तो मुझे क्लैंपर समझाने में लग जाएंगे, उसके बाद भी आपको क्लियर नहीं होगा कि ठीक है, क्योंकि अभी HPCL के एग्जाम में सरफेस लेवल पे क्वेश्चन आएंगे, तो इट इज अ क्विक रिवीजन सीरीज। तो देखो क्लैंपर है, जैसे ये डायग्राम दे देगा, और ये कैपेसिटर है, डायोड है, ये आर मतलब आरएल है, ये लोड रजिस्टर है। समटाइम्स ये लोड नहीं भी देगा, ऐसा भी दे देगा डायग्राम ओनली, नो प्रॉब्लम, ठीक है, बाद में आरएल लगा देंगे। तो दिस इज द पार्ट। अब कैसे समझ में आएगा क्लैंपर है, या फिर ऐसा भी दे देगा। तीन तरीके हैं इसके। यहाँ पे एक बैटरी भी लगी है, बाइसिंग, ठीक है, ये बाइसिंग है। तो अगर आपका एरो नीचे की तरफ है, देखो ये डायोड से करंट कैसे जाता है, नीचे की तरफ, पॉजिटिव से नेगेटिव की तरफ, यहां भी जाएगा। याद रखना पूरी वेवफॉर्म नीचे जा रही है, इससे आप समझ सकते हो। तो दैट इज व्हाट नेगेटिव क्लैंपर। ये कौन सा क्लैंपर है, नेगेटिव क्लैंपर। अब ये भी नेगेटिव क्लैंपर है, ये भी आपका नेगेटिव क्लैंपर हो गया। अब देखो पॉजिटिव क्लैंपर में क्या होगा, देखो आपका डायोड उल्टा लग गया। ये ऐसा भी सर्किट हो सकता है कि आपको आरएल ना दे, या फिर आपका एक बैटरी के साथ सर्किट हो सकता है। दिस इज द विद बैटरी। व्हाट इज द एरो अबव, करंट विल फ्लो फ्रॉम पी साइड टू एन साइड। तो ये याद रखने का तरीका है, दैट इज व्हाट अबव। तो दिस इज अ पॉजिटिव क्लैंपर, पॉजिटिव क्लैंपर, ओके। अब इस बैटरी का क्या यूज है और कैसे आपको समझना है, क्वेश्चन कैसे बनेंगे। तो ये एक तो याद रखिए, विद द पोजीशन ऑफ द डायोड, दिस इज द नेगेटिव क्लैंपर एंड दैट इज द पॉजिटिव क्लैंपर गाइस, ठीक है। 1 मिनट, ये आ गया आपका नेगेटिव क्लैंपर, डायोड, एंड दैट इज द पॉजिटिव क्लैंपर। अब आते फॉर एग्जांपल, this is the biased negative clamper, means just battery is connected. For example, if the 2 volt battery is connected, so always remember that is the diode negative clamper. 2 volt is connected means watch the polarity of the diode, it is a positive value. So what is the answer? For example, that is the input, directly you can draw the output. How? It is a negative clamper. Watch this, what is the value of the battery? 2 volt. So its highest value is what? 2 volt. Its highest value is 2 volt. What is the lowest value? Because the swing will remain same, swing is 20, so 2 minus 20 is what? 2 minus 20 is minus 18. The lowest value is minus 18. Lowest value is minus 18. Now what will be the output? That will be the output. The shape will remain same, swing will remain same, so that is the output. So watch this battery, watch this, it is a negative clamper, highest level is 2, minus swing, the lowest level will become minus 18. What is the DC level? Always maximum plus minimum divided by 2. DC you can find like this, 2 minus 18 divided by 2, that is what? Minus 8. You will get minus 8 is the is its DC level, is its DC level. Here is the minus 8. DC level is minus 8. This is the gap is 10, this gap is what? 10. Minus 8 is the DC, maximum plus minimum divided by 2. Now if suppose we are just changing the polarity of that, so if suppose it is negative, right, then what will be the output? Always remember, if it is negative, right, change the polarity, niche downward, it is a negative clamper. What is the change here? Only one change. This is the 0 level, highest level will become minus 2, highest level will become minus 2, this is the minus 2. And lowest level, what is the swing here? 20, so minus 2 minus 20, the lowest level is minus 22, lowest level will become minus 22, and we are getting same output, square wave, and so on. So swing will remain same, shape will remain same, everything remains same, but according to battery we can say what is the, suppose what will be the question in HPCL, what is the name of this circuit? Simple, it is a negative clamper, it is a negative clamper because it is a downward, and output is clamped at minus 2 volt, output is clamped at minus 2 volt. It is a negative clamper and output is clamped at what? Plus 2 volt. So that will be the answer. If suppose nothing is connected, output is clamped at 0 volt, output is clamped at 0 volt. So if the positive, then it is clamped at plus 2 volt. If it is negative, then it is clamped at minus 2 volt. And how to get the output? Same logic for positive clamper. This is the, always watch the diode. It is a positive clamper and output is clamped at what? 2 volt. For example, that is the input. Then its lowest level is what? 2 volt. Highest level, what is the swing? 20, to highest level will become 22. And that will be the output, like this. Because this is the 2, it is a positive clamper. So output is clamped at 2 volt and above. Similarly, if it is minus, similarly if it is a, we are just changing the polarity, output is clamped at what? Minus 2 volt. That is, there are 4 types of diagram. Only 4 types of diagram, guys. You can understand, you can draw, right? So this is a, please practice it, because this is a very, very important. So clamper means what? We are using the clamper circuit to just to introduce what? DC. It is called DC inserter. Okay, done. Now the clamper is over. Now guys, this type of circuit, if suppose the diode is connected or capacitor is connected, diode is connected or capacitor is only connected, or sometimes here RL is given, and RL is what? Infinity. If this type of circuit is given, capacitor is connected or diode is connected, right? 1 minute. Is it okay? Visible, guys? One minute. Okay. Now, this is a peak detector. If suppose RL is given infinite or RL is not given, in both the cases it is a peak detector. What is the name of this circuit? Peak detector. Means suppose you are giving like this. If you are giving signal like this, and so on, what will happen? For positive half, the diode will on and the capacitor will charge up to first peak. Once the capacitor will charge, diode is off. Now next time the diode will on when the input is greater than the voltage across the capacitor. So this is the, it will hold the value, and next time the input is greater than the voltage across the capacitor, then it will again charge. This green line is what? Voltage across the capacitor. ये जो मैं ड्रॉ कर रहा हूँ वो voltage across the capacitor है. अब यहाँ तक चार्ज हो गया, फिर से इनपुट बढ़ा, फिर ये यहाँ तक चार्ज हो गया. आफ्टर दैट द कैपेसिटर विल नॉट चार्ज एंड द डायोड विल रिमेन ऑफ. फॉर एग्जांपल, द पीक वैल्यू इज 12 वोल्ट. So if the diode is capacitor is charged up to 12 volt or Vi is now less than 12 volt, what about the diode? Is off. That's why the capacitor will not charge. तो अब आप यहाँ पर एक वोल्ट मीटर लाओ और मेजर कर लो. एक वोल्ट मीटर से मेजर करो तो what is the answer? 12 volt. What is the 12 volt? Peak value, and that's why it is called what? Detector. Peak detector. It is a positive peak detector. ये आपको RL देगा या नहीं देगा? It is a positive peak detector. Now change the polarity of the diode, it will become negative peak detector. Negative peak detector. This is the positive and that is the negative. Now, what is the use of this? We are just using it to design what? Voltage doubler. This is the voltage doubler. Now watch this. This is a positive peak detector. Right? Watch this. This is what a watch arrow above. So this is what? Clamper, positive clamper. What is the reference level? 0. It is biased at 0. So it is a positive clamper and it is a positive peak detector. Positive peak detector. Right? Suppose you are giving the input Vm sin omega t. Suppose you are giving the input Vm sin omega t. What is the role of the positive clamper? It will introduce the DC level. So after clamping, you will get this type of output. After clamping, you will get this type of output. Because it is a positive clamper, you will get, this is the output. 2 Vm, Vm and 0. Now it is a peak detector, therefore the capacitor will charge up to highest level. What is the highest level here? 2 Vm, and it will hold the value 2 Vm, and that's why output of this is 2 Vm, and therefore it is called doubler. Therefore it is called voltage doubler. Yeah, positive clamper followed by the positive peak detector, you will get 2 Vm. Now guys, change both the polarity of the diode. Change the polarity of this diode, polarity of this diode. When we are going to change the polarity of both the diodes, this is negative clamper. Watch this. This is a negative clamper. This is what? Negative peak detector, because we have changed the positive. Negative peak detector. So negative clamper followed by the negative peak detector. So after clamping, we are getting this type of output. 0, minus Vm, minus 2 Vm. Because it is a negative clamper. And what is the level? 0. And that's why it is clamped at 0. Now the negative peak detector will detect the negative peak value. So negative peak detector means like this, capacitor will charge like this and it will hold the value. And that's why here you will get minus 2 Vm. Here you will get minus 2 Vm. So they will ask a very, very simple question like this. What is the name of this circuit? So guys, the circuit shown in the figure is best described as, for example, this diode will charge the capacitor during what? Positive half, during negative half, like this. Because current will allow current allowed in this direction from P side to N side, so it will charge up to what? Vm. This diode will on during the positive half. This will charge like this. Now when we are applying the KVL in this loop, you will get the, this is the Vm, this is the minus Vm, so what is the 2 Vm? If suppose this is the voltage, what is the voltage? 2 Vm. Vm minus of minus Vm, 2 Vm. So it is a voltage doubler. This capacitor will charge during negative half, this capacitor will charge during positive half. This is a voltage doubler. So simple, this type of question, voltage doubler. Right, again, so please, this is the assignment. Give me the answer. What is the answer for this question? In comments box, everyone. Bridge rectifier, voltage doubler, rectifier with filter, or what comparator? Two capacitors are connected, diodes are connected, and that is the transformer. It will use to step down. Here we are giving the input, and here we are getting the step down signal, that is called Vi. Like this is the input. Or here we are getting the Vi. Vi is normally represented by what? Vm sin omega t. Or V in is also represented at Vs, that is called Vp sin omega t. After step down, it will become Vm sin omega t. To give me the name of this circuit. What is the name of this circuit, guys? कुछ तो कमेंट्स कीजिए आप लोग. ओहो, जितने जोश में आप हैं, मैं जितने जोश से आप लोगों को पढ़ा रहा हूँ, आप भी उतने ही जोश में रहिए भाई. और यही सब क्वेश्चंस, बेसिक क्वेश्चंस आएंगे, तो ये है थोड़ा सा जल्दी आप रिवाइज कर लीजिए. और परसों फिर से सेशन आने वाला है, दैट इज ऑन बीजेटी. तो एवरीथिंग अबाउट बीजेटी आई एम गोइंग टू डिस्कस. राइट, होप अप टू दिस पॉइंट यू हैव एंजॉयड गाइज. राइट, चलिए अब अगले टॉपिक अगले उसमें कवर करेंगे. आज के लिए इतना ही. तो आपको पीडीएफ चाहिए तो यू कैन ट्यून विद मी. सब्सक्राइब भी कर लीजिएगा चैनल को. देखो भाई, ये जो टॉपिक है ना, जस्ट आई एम गिविंग यू द असाइनमेंट जस्ट टू कवर द वोल्टेज रेगुलेटर. राइट, I have started this session journey to gate on my channel, how to build concept. Here I am covering the daily ka funda plus what daily ka dose. In daily ka funda we are discussing the theory, and in daily ka dose we are solving the question from gate exam. So just for HPCL you can follow that daily ka funda. Here you will get about what? Voltage regulator by using Zener diode, series voltage regulator, shunt voltage regulator. You have to attend the 3 sessions. voltage regulator by using Zener diode. Voltage regulator means series voltage regulator and shunt voltage regulator, 10 minutes only. Within 10 minutes you will get the each and everything about that. So that is on my channel. I have what playlist for that. तो ये हाउ टू बिल्ड द कॉन्सेप्ट डेली का फंडा. तो देखो अदरवाइज आपको ये डायग्राम में आपको शो कर देता हूँ. ये आप लोगों के लिए असाइनमेंट है, आप करोगे तो यस यू विल गेट द आइडिया and you will be able to solve this type of question. That is the case. This is the by using Zener diode, voltage regulator by using Zener diode. This is called what? Series voltage regulator, complete detail about that. And that is what? Shunt voltage regulator, complete detail about that on prep का फंडा, 10 minutes only. अभी देख सकते हो आप, अभी भी अवेलेबल है, राइट? तो आप देखिए जरा. And that is a part of how to build the concept. That is my Telegram channel, Electronics by Sanjay Rathi. I will upload the PDF. Link is given in description. Yes, you can join. And guys, finally, give me the feedback. Give me your comments, right, on my this channel or otherwise what on my Telegram channel, or you can message me on this number 9899940096. तो यहाँ आप मैसेज कर सकते हो. Right? Please note that number. For any queries or anything, you can message me on that. तो चलिए, finally like the session, share the link of this session and subscribe our channel. और याद रखिए, on 17 9 PM we are going to discuss what? BJT, bipolar junction transistor complete. जैसा यहाँ हुआ है ना डायोड, वैसा ही वो भी कवर हो जाएगा. ओके देन, थैंक यू.